Hello everyone. So mostly my today's agenda will be to discuss this Leetcode daily problem, minimum cost to hire K workers. So as per this problem, we have been given n workers. We have been given the quality and wage of each worker. So basically quality of I will denote the quality of work that this worker is doing, and wage of I will denote the minimum wage expectation for the ith worker. And now we want to basically hire K workers such that the amount that we pay is, to this total group is a list, right? So we are basically going to minimize on the amount of money we paid to K workers. And now we have to keep in mind two constraints. The first constraint being each worker in the group must be paid at least their minimum wage expectation, and the second is each worker's pay in the group should be directly proportional to their quality of work. So for example, if we have a worker 1 and worker 2, and if worker 1 has quality of work twice as much as of worker 2, then that should also be reflected in the wages we pay them. So basically worker 1 should be paid twice as much as worker 2. So basically what this second um, constant is telling us that the for a particular group of K workers, the ratio quality by amount, wage paid, should be constant. You can also see from the example that in this example we have been given three workers, but we are selecting only two workers, zero index and zeroth worker, and the second worker, right? So yeah, and in this case you will see that they have selected they're paying 70 to zeroth worker and 35 to second worker, but 35 to second worker, while its minimum wage expectation is 30. So why is that? Because the ratio between their work is basically the ratio between the work of done by the first worker, the zeroth worker, and then that of the second worker is 2 by 1, right? So that is reflected in the pay also. 70 by 35 is 2. Yeah, so that's mostly it. So now the problem is, for a group of K workers we have to select this ratio, and for example also, for let's take this example only, we had quality as 10,5 and 70,30 as the wages. Now we have the option to select two ratios. We have basically two ratios available. One ratio could be 10 by 70 that we are going to keep constant, and if we are going to keep this ratio constant, then the amount for worker 0 will be 70 only. Amount for worker 1, for worker 2 will be 5 by 10 by 70, which will come out to be 35 if you calculate. And if the ratio is we selected as 5 by 30, then the amount for worker 0 will be calculated as 10 by 5 by 30, which will come out to be 60, which is less than minimum wage expectation for worker 0. So it does not work in this case. So from here we can draw a very important conclusion, that the ratio that we select must satisfy these constraints, right? So if we have q1 comma w q1 by w as one ratio, and another is q2 by w, and let's say q1 by w is greater than q2 by w, okay? here if I express it in terms of W2, okay, I can write W1 by Q1 is less than W2 by Q2. So W2 can be written as W1 by Q1 into Q2. So W2 can be rewritten as Q2 by okay, did I do something wrong? Yeah, Q1 by W1, right? So here you will see if I select Q1 by W1 as the ratio, while this is the condition, then we will see the amount of money we pay to worker 2 will be lower than their minimum wage expectation. So if we have a group of K workers, we need to keep in mind that we select the ratio that is the lowest among all these K workers. We select the ratio that is the lowest. That is basically the main idea behind this problem. And once we have selected the ratio, let's call the ratio as C. Okay, if I have the C ratio, though, so the money we pay will be the sum of quality of the workers by C, right? And if we have fixed the C again, then we just need to minimize on the quality, sum of quality basically. Okay, so the main thing is what we are going to do in this problem is first create a vector of basically these ratios and sort that, right? Sort that, and when it is in sorted order, if I'm at a particular ratio, and let's say I'm a particular ratio, and let's call that ratio C. Okay, so every other ratio that comes after it is greater than this. So obviously if I'm at this particular C ratio, and let's say the worker assigned to this particular C ratio is worker. Okay, let's call that worker only. So I can say that obviously I'm selecting this worker for to be included in my group, and I need other K-1 workers to be included, and I need to select those only from the ratios that come after C, right? Because those are only greater than this. So if I want the ratio for the group to be C, we need obviously other ones to be greater than C. So yeah, that's mostly the funda. So we are going to, if I'm at a particular I, we are going to select K-1 other workers such that their that come after this particular I, such that their quality is minimized. So obviously one way of doing that would be to basically iterate over the vector, selecting the I, and then iterating over the elements after that come after I, and then you minimize on the, basically select the K-1 minimum quality values, right? But that would mean a higher time complexity. We can also do something better, which is basically using a max heap. So I'm going to explain it mostly as I write the code. So let's say the number of workers is obviously n, and now I am going to create that vector. Let's call it ratios, and now I'm going to iterate over the workers, and I'm going to push the ratio. Okay, so basically the vector is a pair of double comma int. So double indicating the ratio, and int will be basically the index of that particular worker, because we are going to sort this ratios array, and the ordering might be changed. So we need to also track down the worker assigned to a particular ratio. So yeah, that's the purpose. Okay, this is all right, and then we sort. Now we will have a double answer, which will be initialize to maximum value, and we are also going to have a sum value which will denote the minimum, I mean the basically the sum, minimum sum of the k minus 1 other that quality values, right? K minus 1 other quality values. So now what we are going to do is to optimize on that particular selecting k minus 1 other quality values. What we can do is we are obviously going to iterate over this ratios array, and if I am at a particular I can say obviously as I said, all the other ratios that come after it we need to select from them. So what if instead of iterating from front to back, we iterate from back to front, okay? And we encounter the higher values first, and we store these higher values in a priority queue, in a basically a max heap, okay? And we push we push their corresponding qualities, I mean quality values into this priority queue, and we always maintain the priority queue in such a way that the maximum number of elements in the priority queue is always k minus 1. So how do we do that? If basically the number of elements exceeds k minus 1, we pop out the element with the highest quality value. So that way we can always minimize the sum that is present in our priority queue as we encounter the elements from back to front. So that's mostly the idea. So we have this priority queue, and now let's iterate this. Okay, let's make also this double, right? Now we iterate from front back to front. We have this worker as ratios of I dot second. One thing, let's also get the quality of this worker q, quality as q, which will be quality of worker. Now if I see, I only can do anything with this particular ratio and this worker if we have already encountered at least k minus 1 other workers before. So I'll say if k minus 1 pq dot size, so then I get the ratio. We can use auto here actually. Okay, now what I'm going to do is calculate the answer. Q plus sum divided by our ratio, right? Okay, now we push this q value to this, update the sum, and if we see that pq dot size has exceeded k minus 1, basically it has become k, then we pop out the highest element from the queue, I mean quality values. So this should mostly work. Okay, yeah, it should be pushed back. Okay, yeah, so that's mostly it about this problem. Thanks.